Alright, ladies and gentlemen, we are looking today at special products. These are basically patterns that allow us to quickly and easily square a binomial by using the following patterns, right? The first two are called perfect square trinomials, so the patterns for perfect square trinomials. And the last one also, it allows us to find the product of the sum and difference of two terms by using this pattern as well. So the main thing is to be able to recognize them, right? When we are expanding, it will save us a lot of time, but definitely it will save us a lot more time when we start looking at factoring, right? So let us start looking at our first example here, right? We have x plus 4 squared, right? X plus 4 and all of this is squared. Now we can simply go ahead and basically expand this, right? Because we know that this is the same as saying x plus 4 times x plus 4, and if you look at my previous videos, right, you expand this and we're gonna get the same result, right? But if we know the patterns for perfect square trinomials, we can use that knowledge and save ourselves a lot of time, right? So let us start looking at this one. So we're looking at perfect square trinomials. These are the two patterns, right? And basically we have two terms here, a binomial, and there's a plus in between, right? So there's an a plus b squared. So if we look at here at the pattern here, a plus b squared equals to a squared plus 2ab plus b squared. So we can use this pattern, right? So let me just place this here at the top so we can have it as a reference, right? So we're gonna look at that pattern. All right, so the first thing, it would be either mentally, although at the beginning if you're working with these patterns, I would suggest you write down your steps, right, step by step. Alright, so let's start looking at this basically. So this is our a, so we collect our data here. What is our a value? A value would be our x, right? What is our b value? Our b value would be the 4, right? Now we know that there's a 2ab in the middle, right? So we might as well start figuring that out. So 2ab would be what? 2 times x times 4, right? 2 times x times 4, which essentially is equal to 2 times 4, 8 times x, 8x, right? So then all we have to do is substitute our data, right? So here we have a squared. We know what the value of a is. It's going to be x, but we need that to be a square. So a squared is going to give us x squared, right? Plus 2ab. Well, we know that 2ab is going to be 8x, and because there's a plus here, we put a plus here, we write 8x, and then plus b squared, so plus, and b squared, b is 4, so what's 4 squared equal to? 16, right? So this is the answer of our expansion of x plus 4, right? X squared plus 8x plus 16. That is our answer to this. And that is because, well, we saved a lot of time because we were able to recognize and we know what the pattern is, so we can apply that pattern. Now you may be thinking, well, actually that didn't take that wasn't that short, right? It took a long time. Well, it's because I'm going in detail, right? But eventually, once you start getting more familiar with these patterns, you don't have to write a, b, and 2ab, etc. Well, I think this is quite obvious. Let's move on to another example, very similar as well. We have b 3y plus 6 squared. Now I would suggest for you guys to pause the video right now, try it for yourselves, and then compare it with my answer, right? Okay, good. So now this is the way we would do it, right? This is our A value, this is our B value. You know there's a plus in the middle, so we're gonna have to use our pattern, right? The pattern, which is basically, I'm gonna write it here as a reference to our perfect square trinomial since it's off the screen, right? But the pattern is basically A plus B squared, A squared plus 2AB plus B squared, right? That's the pattern we're gonna use. Okay, so basically you look at the pattern, you think, okay, this is our A, this is our B value, so we need an A squared, so 3y squared is going to give us 9y squared plus 2ab, so plus 2ab, well, we multiply a times b, so that's 18y. 18y times 2 is 36y, and then plus 36, right? And that's it, that's our answer. All right, if you still have any questions, you can let me know next time when we meet, right? Okay, let's start looking at another example here, but in this occasion we have x minus 6 squared, right? Same thing. This is a perfect, well, we recognize this as a binomial that is squared, right? And we can use our perfect square trinomial pattern, right? And in this case we will be using the second one here. For now I'm covering the last one because we will see more examples about that, but covering that one. Okay, this a minus b, right? Why? Because, sorry, let me move this up a little more, right? We will be using the second one because there's a minus in there, right? So a minus b squared, so a minus b, so our a value would be the x, our b value would be the 6, and then we simply apply this pattern, right? Okay, so let's start looking at this now. So we have, what's our a value? Our a value would be x, our b value would be the 6, and our 2ab value would be x times 6, 6x times 2, it's 12x. So then all we have to do is apply, right? We have to do, in this case, we will be doing this pattern, right? Let's write it here as a reference, a minus b squared, a squared, because there's a minus, we put minus 2ab plus b squared, right? Okay, so the answer for x minus 6 squared, when we expand it, is going to be, right? And in fact, I'm just rewriting the question here. It's going to be x squared. There's a minus there, minus 2ab. We know that 2ab is going to be 12x, so minus 12x. And then the last one, plus 36, right? Plus 36, minus 2ab plus 36. So that's our answer, right? That's our answer. Okay. Now, same thing as before. I want you to try this. Maybe pause the video for a few seconds, maybe, and let's compare the answers. All right. Well, okay. So the answer to this is the following, right? This is our a value. This is our b value. There's a minus in between. We can use this pattern to solve for that. So you simply look at this and you go, okay. So a squared is going to be 64a squared. Right, there's going to be a minus 2ab, right? So a times b, 8a times 1, it's 8a times 2, it's 16a, right? a times 2, 16a, and then our last one is going to be plus 1, right? b squared, right? And that is our answer to this one, right? Okay, let's look at a few more examples since I still have a few minutes over here. In fact, well, we've seen already a few examples. You should try some more from your homework. Let's look at some examples of difference of squares, right? Difference of squares. So we have the following, right? So say you're presented with this example, x plus 6 times x minus 6, right? So here we are multiplying the sum and the difference of a term, right? You see that and you think difference of squares. And when you see that, you think of this pattern, right? A plus b times a minus b is equal to a squared minus b squared. This is a difference of squares. So, same thing, right? What is our a value? Our a value would be x, right? What is our b value? It would be 6, right? So then when we expand that, right, we need to get a squared minus b squared. So this is a difference of squares. So in essence, when you expand this, we get x squared minus b squared, which is 36, right? Get familiar with these patterns. Eventually, when we are factoring, this will become very, very useful. All right. Now, we have another example here, right? Same thing. I would suggest, pardon, 6g minus 7h, 6g plus 7h. I would suggest pause the video right now and let's compare answers. All right, good. So the answer to this is the following, right? This is our a value, this is our b value. 6g is equal to a, 7h is equal to b, so this is equal to a squared minus b squared. In other words, 36g squared minus 49h squared, right? And that's it. So it saves you a lot of time once you start getting familiar with the patterns. All right, let's look at some more challenging examples of these, right? Let me move this up now, and let's look at now some examples that have a combination of these, right? So for example, you have 4x squared plus 3y squared, and this whole thing is squared, right? Same thing, and in this time we're not go in detail, right? First you look at this, right, and you think, okay, it's a binomial, it's being squared, right? What is our a value? What is our b value, right? So mentally you would be doing this, and then you would be thinking, okay, well, the pattern for this is going to be a squared plus 2ab, right? So we will be dealing with this. I'm going to write it here once again as a reference, right? A squared plus 2ab plus b squared, right? So now let's start collecting what we have, right? What's our a value? Our a value would be 4x squared, right? We know that. Okay, what is our b value? Our b value would be 3y squared, right? What is our 2ab value, right? So we multiply these two times 2, right? So 2 times, what's 4x squared times 3y squared? So 4 times 3, 12x squared y squared, right? And then if we bring this in, we're going to end up with 24x squared y squared, right? Okay, so let's start expanding this very quickly. So the answer to that is going to be, right, a squared. So a squared is what? 4x squared. Everything to the power of 2 is going to give us what? 4 times 4 is 16. X squared times x squared is x to the 4th, right? Then we have plus 24 x squared y squared, because that's our 2ab, plus what is our b squared? So b squared is 3y squared, so that when we square that, it's going to give us 9y to the power of 4, right? Okay, and let's look at one more example. Actually, one more example just like that one, very similar. But now we're going to be looking at a difference of squares, right? So we have 3x squared plus 2y squared, and then we have 3x squared minus 2y squared, right? So here you're looking at the sum of a term and the difference of a term, right, being multiplied. So you look at this and you think difference of squares. Okay, so it's basically a squared minus b squared, right? If you recall, right? Difference of squares, a squared, right? A squared minus b squared is equal to this pattern. So let's use that knowledge, right? And once again, let's see, maybe you want to pause the video, but the answer to this would be, right, so pause it, then you play it again, and the answer to this is what? A squared. So what's a squared equals to? 3 times 3, 9. Well, our a value is 3x squared, so when you square this gives us 9x to the 4th minus, because it's a difference of squares, b squared. So a squared minus b squared. This is 4y to the power of 4, right? So this saves us a lot of time, right? We could have gone and expanded this, and you can imagine we would have ended up with many lines going down, but this saves us a lot of time. All right, there are two more examples. Right, we have x minus 3 squared minus x plus 3 times x minus 3. So here, same thing, use what you just learned in this video, but you have to afterwards perhaps collect some data, collect some like terms, right? But same thing here, right? Use what you just learned. And this is another example too. 2b plus 1, 2b minus 1, right, plus b minus 3 squared. Same thing, right? Same thing. Perhaps here you may have to bring the 3 afterwards, right? So work on these two examples. We'll take them up next time when we meet, and that's all. And also work on the problem solving question. See you next time.